Okay, we're back and ready for Part B. Part B says, assume 85 companies were included in the sample. So that tells us that we have a sample size of 85. And it says, what is the p-value for your hypothesis test? So, first of all, in order to get the p-value, we have to calculate the test statistic. And we know that because we are hypothesizing about the mean and we're using a sample standard deviation instead of a population standard deviation, we're going to use a t-value to calculate the p-value. If this had been population standard deviation, then we would have used a z. But since we're using sample standard deviation, we use a t-value. And the formula is very similar. It is t equals the sample mean minus the population mean divided by the sample standard deviation divided by the square root of the sample size. And that formula can be found on page, let's see here. Well, you guys can probably see in your book. On page 373. 373 has that formula. Okay, now we're ready just to plug in our numbers to calculate the t. So our sample mean is 7.27. Let's give them back in the original problem. Minus the population mean, what you're hypothesizing about, is 9. Divided by the sample standard deviation, which was given as 6.38. Divided by the square root of the sample size, and the sample size was given to be 85. So when you plug all those numbers into your calculator or whatever, and you do the calculations, you come up with, all right, over here, negative 2.5. Okay, so that's our t-value. Now, in order to turn our t-value into a p-value, again, I'm going to use the computer because I think that is a little bit easier to do. So, in your book, it shows you how to do this. You're going to use, it shows you there on page 376, we're going to use the function key of t distribution, and then you'll open the parentheses, and the test statistic is the number you just calculated, 2.5. Then it asks for the degrees of freedom. Degree of freedom is always your sample size minus 1. So degree of freedom is going to be 85 minus 1. So we're going to plug in 84 right there. And then the next thing asks if it's a two-tail or a one-tail. And because if it was an equal to here, it'd be a two-tail. But because we're looking for the probability of being greater than, okay, then we have a one-tail. Okay. So when you put that into Excel, you get a p-value of 0.00718. Okay. So that's part B. We'll do part C here real quick. Part C says, at a 1% level of significance, okay, what is your conclusion? So we're going to use the same thing as we did before, but if you don't remember, there's a table there on the bottom of page 378. If the p-value is less than or equal to the level of significance, then you reject. And our p-value is 0.00718, and it is in fact less than 0.01. So therefore we're going to reject our null hypothesis. If this had been greater than 0.01, we would have accepted. But it is less than, so we're going to reject, and we're rejecting that the average tenure is greater than or at least 9, greater than or equal to or at least 9. So we have proven, since we rejected that, we accept this, that the average tenure is actually in fact less than 9 years. So we prove that the mean is less than 9. Okay. And that's how you do 28.